Hearing is the basis of all oral language development. Last year, the WHO declared that there are about 1 billion children at risk for hearing loss. The focus of our work is looking at a very special group of these children who have deafness that can't be helped with hearing aids or cochlear implants. Our work, funded by the Bird Rally program, is meant to really improve the care through the use of a new generation auditory brainstem implant. The Bird Rally program in neuroscience and neuroengineering has been a vital part of our mission, which is to try to improve a special device called an auditory brainstem implant. The work is a collaboration between Boston, the Mass Eye and Ear, and Harvard Medical School, and the EPFL, led by Professor Stephanie LaCour's team. And the focus is really trying to help a new generation electrode system that will help to improve the connection between the machine and the patient. Sound is captured through the outer ear called the auricle, and the first place that information goes to is in the auditory brainstem. Patients who do not have a functional inner ear cannot receive a cochlear implant. And an auditory brainstem implant will bypass the hairs or hair cells that aren't working to directly activate the auditory nerve.
Push. Is it broken? Is it broken? Kara was born completely deaf. She was born without cochleas and without auditory nerves. So there was absolutely no chance of her hearing or having a cochlear implant. The only chance of her hearing was with an auditory brainstem implant.
Kara is a spectacular little girl, and she received her auditory brainstem implant several years ago.
Yeah, brush, brush.
She's able to hear sounds and form words, and she's developing a vocabulary as well.
Oh, it's gonna shoot. To have her respond to your voice when given such a slim chance that that will happen is just amazing. Jump.
Jump.
Hit it. Absolutely amazing.
The problem is this brainstem implant doesn't work very well for quite a lot of children.
So we want to explore how we can use advanced technologies to stimulate better the auditory brainstem.
So when our daughter was born,
Hi.
so the cochlear implant, it didn't work. I slam doors, I pop balloons, I do loud music. She's still not reacting.
Arianna is a very special girl in our practice who underwent auditory brainstem implant surgery just really 2 or 3 months ago.
And they're doing the activation with us in the room. I don't know about you, but I'm
nervous.
I'm nervous, I'm excited. There's a lot going on.
It's a lot of feelings right now.
Yeah.
It's hard to explain. Maybe she might be going to be able to hear us.
In a nutshell, the clinical ABI electrode array is a very stiff device, and it does not conform to the surface of the brainstem. The brainstem is curved. You can imagine that electrodes on this device are not even touching the brainstem and won't work very well.
So in the first phase of the project, we're revisiting how to design the implant so that it is perfectly aligned with the anatomy of the brainstem. Using materials that are fully elastic, so you can stretch them, you can shape them over any sort of complicated structure.
And you can imagine that because these electrodes are then touching the brainstem surface, they're going to work much better.
And the second area is to try to understand the possibilities of using an entirely different way to communicate with the brain, and that is the use of light.
So when you compare light and electricity, With light, you can focus the beam of light to a very discrete region of neurons.
And we've been exploring how we can put this very tiny light onto our array.
And hopefully in the future provide better hearing sensations for the patient.
However, we do not yet have approval to implant these electrode arrays in humans. So we are now testing them to ensure that they work better and that they are durable in our research laboratory.
But we had tried to condition her to always look when she heard at the toy. I'm not sure. I am not completely convinced of what she's hearing. But it was a nice response to have her turn over to the elephant to say, oh, is that thing supposed to go on or not? There's a long way to go.
So that gave me a lot of hopes, and for right now I think we're really happy because we think that's something. So baby steps, that's all we need.
We've seen some really encouraging clinical data thus far, which gives us the impetus to continue this work. There's still a lot we need to learn.
We're close. These implants are being put in patients, so let's try to make them work better. Without the Bertarelli Foundation, none of this would have come to pass.
The Bertarelli program supporting our auditory brainstem implant research, I think, will help to provide hope for new patients.
And we hope to be able to use this technology and explore different medical contexts.
We could tell that she can hear faint sounds already. So we know that there's the light at the end of the tunnel. It's going to be a brighter future for Arianna.